Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all today's session on random variables and probability distributions, part 3. Let us recall the previous session. In the last session, we have discussed the discrete and continuous random variables, the definition, the types of random variables. There are two types of random variables, discrete and continuous. So, what is a discrete random variable and what is a continuous random variable, that we have discussed in the last class. If the random variable capital X takes finite number of values, then it is said to be finite number of values, then it is said to be discrete random variable. If capital X takes infinite number of values, then it is said to be a continuous random variable. Then the probability function corresponding to the values of random variable, we find the probability using a function which is called the probability function. So, using this P of X, we can calculate the corresponding probabilities, which is called probability function. And there are two types of probability functions. For discrete random variable, it is called mass function. For continuous random variable, it is called probability density function. And the probability distribution, simply finding the values of the random variable capital X and corresponding probabilities and arranging all in the form of a table, that is called probability distribution, or the set of values of xi and corresponding probability P of xi. So, this is called probability distribution. And cumulative probability distribution function, we can find the sum of the probabilities. For example, probability of x less than or equal to small x, some number, probability of x less than or equal to 6, which is called the cumulative probability distribution function. And also we have introduced the measures of central tendency, mean, median, mode, variance and standard deviation. Now, in the today's presentation, we will discuss about mean, median, mode of a random variable and how to find these values, these statistical measurements, similarly variance and standard deviation. And we know that the mean, which is also called average, mean or average or expectation. So, here the definition of expectation is the mathematical expectation or mean or average, expectation or mean or average, all these are one and the same, or expected value of a random variable is denoted by mu. So, we denote the mean or average by mu. And since we are using this expected value, so it is denoted by capital E of x. So, mu equal to E of x, which is defined as, now we have two different types of random variables, discrete and continuous. So, in discrete case, we use sigma notation, and in continuous case, we use integral notation. In discrete case, sigma notation, and in continuous case, integral notation. So, the expectation or expected value of a random variable capital X is given by sum of the products of xi and pi. So, simply from the probability distribution, for example, there are 6 values for x, x1, x2, x3, x4, x5 and x6, and corresponding to each random variable value, we can calculate the probabilities p1, p2, p3, p4, p5, p6. So, this is called the probability distribution of capital X. Now, let us multiply the corresponding elements x1 into p1, similarly plus x2 into p2 plus so on x6 into p6. So, sum of the products of these values, that is sigma xi into pi, which is called the expectation of x or the mean or average in the case of discrete random variable. Similarly, in the case of continuous random variable, since x takes infinite number of values, we use the integral notation and integrate the product of xi and f at xi between minus infinity to plus infinity. So, this is the definition of expectation or mean or average of random variable. And coming to the properties of expectation, let us consider a random variable x. In general, we know the random variables are denoted by capital letters x, y, z and so on. So, here x is a random variable and this k is a constant. Now, expectation of x plus k is expectation of x plus k. So from this we can observe that the expectation of a constant is constant itself. It's not equal to 0 or any other value. Expectation of a constant is again the constant. For example, expectation of 2, the answer is 2 itself, the same constant. And expectation of k multiplied by x, k into x, which is, we can write this k outside of that expectation. So k into expectation of x. Similarly, expectation of ax plus b is a into expectation of x plus b is a constant. So expectation of constant is again the same constant. Hence the result is expectation of a into expectation of x plus b. And similarly, expectation of x plus or minus y, we can use minus also here. Expectation of x plus or minus expectation of y. And there is a special property that expectation of x into y is equal to expectation of x into expectation of y when the random variables x and y are independent. If x and y are independent, then only this condition holds. Otherwise, we cannot use this property. So if x and y are independent, then expectation of product of two random variables is product of individual expectations. Expectation of xy equal to expectation of x into expectation of y. So this is about expectation or mean or average or expected value of a random variable. Now median. Median is the point which divides the entire distribution into two equal parts. Median is a point that divides the entire distribution into two equal parts. In the case of, for example, in the case of continuous distribution, median is the point which divides the total area into two equal areas. And if n is the median of the distribution, that can be calculated using the following. If x is discrete random variable, just now we have defined, divides the entire distribution into two equal parts. So sigma from a to m f of x is equal to sigma from m to b f of x, each value is equal to 1 by 2, half. Similarly, integral a to m f of x dx is equal to integral m to b f of x dx, which is equal to half in the case of continuous random variable. So in the case of continuous distribution, the probability can be calculated by finding the area. So here it divides the total area into exactly two equal parts, and each value will be equal to half. So median divides the distribution into two equal parts. Now coming to the next definition, mode. Mode is the value of x at which f of x is maximum. So here f of x which is the probability function. So we have to find the value of x at which this probability attains its maximum value. That means the function attains its maximum value. So mode is the value of x at which f of x is maximum. Now the next definition is variance. Variance of a random variable capital X. The notation is given by variance of x. We can use the first three letters of variance. So VAR of capital X or sigma square of x. So this sigma square is the usual notation. To denote variance, we use this sigma square. So variance of a random variable is denoted by sigma square and is defined as sigma square of x is expectation of x minus mu whole square. That means here x means it has some values, for example x1, x2, etc. xn, and we can find the mean of the distribution. Just now we defined the expectation, mu is nothing but expectation of x. Let us calculate that mu and subtract that mu from each and every individual of x values. So capital X minus mu and square such values and take the sum. So sum of the squares of deviations. Variance characterizes the variability of the values about the mean. So from each individual value we are subtracting mu. It characterizes the variability of the values about its mean. And we can use a standard formula. The above formula can be written as sigma square of x is expectation of x square minus expectation of x whole square. So expectation of x square minus expectation of x whole square, which is expectation of x square minus mu square, where this mu is the mean or expected value of x. Now, how can we find this expectation of x square? As just now we have defined, expectation of x is, in the case of discrete random variable, xi into pi. Then expectation of x square will be, you just square the elements of x and then multiply with pi. Sum of the products with xi square. So, this gives expectation of x square. Similarly, in the case of continuous random variable, x square into p of x, this is expectation of x square. So, here there are two formulae for variance. Either we can use expectation of x minus mu whole square, this one, or else expectation of x square minus expectation of x whole square. Depending on the given data, we can use any one of these two formulae. The properties of variance. Variance of a constant is 0. So, this is an important property. Whereas, in the previous case, expectation of a constant is again the constant itself, the same constant. Expectation of 2 is again 2, but variance of 2 is 0. Variance of a constant is 0. Similarly, variance of k into x, where k is the constant, then k square into v of x, it results as k square into v of x. That is, in the previous case, expectation of k into x is k into expectation of x. Simply we can write that constant outside. But variance of kx is k square into variance of x. And similarly, variance of x plus k, since variance of k is 0, variance of 2 is 0, variance of some constant is 0, variance of x plus k is equal to variance of x. And similarly, variance of ax plus b, the same, where a is a constant, b is another constant, a square into v of x plus 0, because variance of a constant is 0. And if x and y are two independent random variables, then variance of x plus r minus y is equal to sum of the individual variances v of x plus v of y, or v of x minus v of y. So, these are the properties of variances. Now, the next definition is standard deviation. Simply, the standard deviation is the positive square root of variance. Already we have denoted variance as sigma square. Now, let us take the square root of this variance. In general, it results as plus or minus, either plus or minus, but since all these values are statistical measurements which cannot be negative, we consider only the positive value of sigma square. So, positive value of sigma square is simply sigma. So, the standard deviation of a random variable is denoted by sigma. So, sigma is the positive square root of variance of x. Now, let us discuss some problems on these random variables and probability distributions. Now, the first one, let capital X be a random variable that denotes the number of heads in tossing 4 coins. So, here 4 coins are tossed and capital X is a random variable that denotes number of heads. Capital X is a random variable that denotes number of heads in tossing 4 coins. Now, the question is to determine probability of x less than 2, probability of 1 less than x less than or equal to 3 and expectation of x. Just now we have discussed, to find the expectation of x, first we must have the probability distribution, and to find the probability distribution, first we need to find the values of x. The random variable takes some values. Here solution, given this capital X denotes the number of heads, and here how many coins are tossed? 4 coins are tossed. So, if 4 coins are tossed, maximum number of heads possible are, can we get 5 heads? Which is not possible. Since 4 coins are tossed, the possible number of heads, the maximum value is 4. So, x takes the values, capital X, maximum 4 heads or 3 heads and 1 tail, 2 heads and 2 tails, 1 head and 3 tails, or 0 heads, and that means all 4 tails. So, x takes the values 0, 1, 2, 3, 4. Since the values of x Our total number of values 5, which is a finite number. This comes under discrete probability distribution. So here capital X takes the values 0, 1, 2, 3 and 4. Now we need to calculate the corresponding probabilities, probability of each value. And here, since 4 coins are tossed, the sample space S contains 2 power 4 16 elements. The sample space contains 2 power 4, that means 16 elements. So for example, all 4 heads or 3 heads and 1 tail, and this is possible in 3 different ways, total 4 different ways, and 2 heads and 2 tails, like that all tails. There will be 16 outcomes. Now we need to calculate the probabilities of corresponding of these X values. Now here capital X takes the values 0, 1, 2, 3 and 4. Since 4 coins are tossed, maximum number of heads is 4 and minimum is 0. And using the classical definition of probability, how many times, what are the possibilities to get 0 number of heads? That means one and only one case, all outcomes must be tail. So out of 16 elements, only one case is favorable to the first one. Similarly, all 4 heads are possible one and only one way. This one, all 4 heads, and this one, all 4 tails. So probability of 0 is 1 by 16 and probability of getting 4 heads is 1 by 16. Similarly, 1 head is possible in 4 different ways and 2 heads are possible in 6 different ways, 3 heads are possible in 4 different ways. So this is the probability distribution. So if you have the random variable, values of random variable, and if you know the experiment, let us first find the probability distribution. Construct the table, X values and corresponding probabilities. Then we can find the required probabilities. Now in the given question, we need to calculate probability of X less than 2. So the first question is probability of X less than 2. And here this is a discrete random variable. X is a discrete random variable since it takes only 5 values, a finite number. So the distribution is discrete probability distribution. In discrete probability distribution, less than and less than or equal to are having different meanings. These are not the same. Less than means strictly less than. Less than or equal to, we can include that value also. So here probability of X less than 2. X less than 2 means up to here. So probability of X equal to 0 plus probability of X equal to 1. We should not include 2. This is excluding 2 because strictly less than is there. And what is the probability of X equal to 0? 1 by 16 plus probability of X equal to 1 is 4 by 16. So the answer is 5 by 16. You can calculate the numerical answer using Calci. Similarly, the second question, probability of X lies between 1 and 3, and here 1 excluding and 3 including. So less than and less than or equal to are not the same in the case of discrete random variable. Similarly, greater than and greater than or equal to are not the same in discrete case. So 1 less than X less than or equal to 3. 1 less than X less than or equal to 3. Strictly less than. So it starts from 2 plus, here we have equality. So probability of X equal to 3 also. 2 plus 3. And what is the probability of X equal to 2? 6 by 16 plus X equal to 3, 4 by 16, which is 10 by 16, 5 by 8, 0.4. That we can calculate. Using calculator, you can find this numerical answer also. And similarly, coming to the third one, in the third question, we need to find the expectation of X. So to find the expectation of X, first we must have this probability distribution. So by the definition of expectation of a random variable, since this is a discrete case, this definition is sigma xi into pi. So 0 into 1 by 16, this is for the first value, plus 1 into 4 by 16 plus 2 into 6 by 16 plus 3 into 4 by 16 plus 4 into 1 by 16. Sum of the products, multiply the corresponding values and add. That gives the average or the mean or expectation of random variable. So, this results as 32 by 16 and the answer is 2. And here this is the expected value or expectation or mean, and first two are probabilities, and we know that the probability of an event that lies between 0 and 1 can be 0 and can be equal to 1 also, but it cannot be negative and more than 1 also, lies between 0 and 1. And here the expectation of x is not the probability. This gives the mean value or average of the distribution. So, it can be any other value. So, here the answer is 2. Now, let us consider another example. 2 dice are thrown. Let x be a random variable that denotes the maximum number that appears. So, here the experiment is given 2 dice are thrown. 2 dice are thrown. So, we know that the sample space contains 36 elements. And those elements are given by 1, 1, 1, 2 and so on 1, 6, 2, 1, 2, 2 and so on 2, 6. Like that, let us fix the number 6 on the first die and change the number on the second die, 6, 2 and so on 6, 6. So, these are the possible outcomes, total 36 outcomes. Now, here in the problem itself it is clearly mentioned the random variable or clearly defined the random variable capital X as the maximum number that appears. So, here out of these 36 cases, if you consider the first case 1, 1, 1 can be the maximum as there is no other number which is greater than 1. So, maximum number 1 is possible in this case. Similarly, 2 is maximum when 1, 2, 2, 1 and 2, 2. Similarly, 3 is possible, 4, 5 and 6, 6. 6 is the maximum value as there is no other number which is greater than 6. So, the possible values for capital X are 1 to 6, 1, 2, 3, 4, 5 and 6. Now, first we need to find the probability distribution. That means set of values of xi and corresponding probabilities. Now, coming to this x equal to 1, the probability of getting number 1 as maximum, there is only one and only one favorable case for this 1, 1. Out of 36 cases, only one case is favorable for this event. Similarly, 2 is maximum in 2, 1, 2, 2 and 1, 2. There are 3 favorable cases out of 36 and 3 is maximum 1, 3, 2, 3, 3, 3, 3, 2 and 3, 1. So, there are 5 cases, 5 favorable cases to get 3 as maximum number. So, 5 by 36, 7 by 36 for 4, 9 by 36 for 5 and 11 by 36 for 6. So, this is the probability distribution of capital X, which is the maximum number that appeared when 2 dice are thrown. So, if we have this probability distribution, we can find the next mean, median, mode or variance, etc., any required value. So, here the first question is to find the probability distribution of X. So, we have given X values and corresponding probabilities also. Now, coming to the mean, mu is expectation of X. So, which is, since this is the discrete case, xi into pi. This is xi into pi. So, multiply the corresponding elements 1 into 1 by 36 plus 3 into 2 into 3 by 36 plus and so on 6 into 11 by 36. So, sum of the products, this results when we calculate this becomes 4.47. So, the mean or average or the expectation is given by 4.47. Similarly, we need to calculate the variance also. So, to find the variance of capital X, we have the formula expectation of x square minus expectation of x whole square. So, expectation of x square minus expectation of x, just now we have calculated as 4.47 whole square. And how to find this expectation of x square? We have the definition, just square the values of x and then multiply. So, xi square into pi. So, that means 1 square into the corresponding probability 1 by 36 plus 2 square into 3 by 36, 3 square into 5 by 36, 4 square into 6 by 36, 5 square into this is 7 by 36, 9 by 36 and 6 square into 11 by 36. So, this value results as 21.97, and substituting this value in the variance of x, which is sigma square, is expectation of x square minus expectation of x whole square, 4.47 whole square. So, which results as 1.99. Similarly, we can find the standard deviation also, which is sigma, the positive square root of the variance, that is the standard deviation. So, like this we can calculate the statistical measurements if we have the probability distribution. So, if you have the x values and corresponding probabilities, we can find the statistical measurements. Now, coming to the summary of today's presentation. In the today's session, measures of central tendency, that means the mean, variance, standard deviation, mode, median, and the definition of all these, and we have discussed 2 problems on probability distributions also. So, in the next session again we discuss the problems on discrete probability distribution and continuous probability distribution. Thank you.